Okay, so hello everyone. Today we are going to discuss about simple harmonic motion, another type, which is motion under elastic restoring force. Okay, so yeah, just have a look. First of all, here we will just take one mass, a body of a mass, which is attached with the spring. Okay, and that is known as an spring have the constant spring. We can say constant unit, which is K. So for example, we have this one. Okay. So this is the body or a mass M which is attached with the spring. And this spring have a spring constant which is K. And this remember this is the smooth surface. After that there is the frictionless, okay? Smooth and frictionless. So now here we are going with this. So first of all, remember this. The spring will exert the force on a body. ये जो if we can say putting the force on this object or this mass on this side. अगर मैं इस side पर force लगा रही हूँ, so this spring will put the force against the direction which is elastic restoring force. This spring will put the force against this, we can say, displacement, so that will be elastic restoring force. So here it will be F is equal to minus kx. Or simply, first of all, let me tell you not this. Yeah, basic force is directly proportional to displacement. फोर्स डायरेक्टली प्रोपोर्शनल किसके साथ है, डिस्प्लेसमेंट के साथ. बट हेयर आई पुट द नेगेटिव बिकॉज वो डिस्प्लेसमेंट कहाँ है, वो डिस्प्लेसमेंट नेगेटिव पे लग रही है. Okay, after that when we remove this, we can say this directly proportional sign or is equal to sign, we'll put constant. That will be F is equal to K minus K X. So this is known as, we can say, Hooke's law, and here K is known as spring force or spring constant. Spring force or spring constant. Okay, after that here you may look into it. Now we have to find out the spring constant, which is K. So here K will be equal to what? K will be equal to force into displacement, because the displacement is multiplying, it will go there to be dividing. So to find out the spring constant value in some questions, we will use force per unit displacement. Now if I talk about the SI unit of this spring constant, the SI unit is force unit is Newton, displacement unit is meter, so it will be Newton per meter, or it is also known as Newton meter inverse. Okay, so now here I'll be applying according to the Newton's second law of motion. According to Newton's second law of motion, we know that force is directly proportional to, we can say, mass and acceleration. Directly proportional to mass and acceleration. And here I have gotten K force is equal to minus Kx is equal to ma. Okay, to find the acceleration from here, it will be a is equal to minus k upon m into x. Okay, and here this, we can say, acceleration is for what? This is the acceleration for the spring. Acceleration for the mass spring system. Mass spring system. But the acceleration which we have studied in the last video, that was acceleration is equal to x omega squared. Now this is the acceleration which was for the uniform circular motion. Okay, so I hope this is clear. The acceleration of this, we can say, mm, simple, we can say elastic restoring force or mass spring system. Now let's prove that either this, we can say, mass spring system will obey SHM or not. क्या ये obey करता है या नहीं? Okay, so here we have basically, yep, acceleration is, we can say, we have gotten the acceleration minus k upon m and x. So remember, now in the spring there will be, the mass will be constant. कोई भी स्प्रिंग मास पर डिपेंड नहीं करेगी. आप कोई सा भी मास ले लो, वो डिपेंड करेगी हमारे पास फोर्स पर, कितनी फोर्स लग रही है, कितना डिस्प्लेस हो रहा है. तो मास भी यहाँ पे कांस्टेंट होगा एंड k इज द कांस्टेंट स्प्रिंग कांस्टेंट यूनिट. So this means this whole term is constant. However, here acceleration is equal to minus x के बराबर, and as I told you, whenever we are removing the is equal to sign, we will put what? We will, removing the is equal to and constant sign, we will put proportionality sign. So x is directly proportional to minus x. So this means it has proved that K, we can say, mass spring system will follow SHM. Mass spring system follow SHM. Okay, I hope it is clear. The next video we will discuss about the time period and frequency. Till that, bye bye.